Cheated. Cheated.
He's on a team with the.
So
They had the native speaker on their team, and she carried them through the entire episode.
Our team had
How many
no
points did you guys have?
13.
0.
Or no, wait, we had the.
We won the 2.
We did it from last
Jeremy
to
was-
second.
Jeremy couldn't do anything.
Nice.
It's Abby's part.
why do I have so many?
She's probably not fast on you.
Ah.
Oh, so this is that.
No, she's smart.
Yes, pop quiz. After we just took a test that I still need to grade.
Wait, this is this.
I don't know. The last name on the side might be an indication.
All it says is Baka.
I'm sorry, you're asking really direct questions. So, for those of you in the true 8th grade, oh my gosh, we're scheduling for high school and all of the world seems too much.
No
Alright,
one's
guys,
acting like
you
that.
didn't. Well, 3 different people have come in and said, we're already on 821. You seem high stress. So,
Well, yeah, because I
no.
thought I had a bunch of homework to make up for.
no high stress. This is the next lesson. And then notice, there's only 2 in 2,
No, there's
2 in 3, and 3 in, like, this, we jumped sections really quickly this chapter. So, refresher, 811 was our constructing triangles. Right? The circumcenter, the incenter, all of those. The centroid, which is the center of weight. Right? Today, we're dealing with angles of a polygon, which are probably mainly refreshing rules that you already know. Well, I'm sorry.
Mr. Hudson, you messed it up.
I'm deeply apologetic. I will forever be indebted to your
Jeez,
heading.
Mr. Hudson, come on.
You
Cheese?
destroyed my heading.
If I have to pick a cheese, it would be pepper jack.
That's a good cheese.
Pretty cheese, spicy cheese. Spicy cheese.
So, those of you flying without a book, this is going to be slightly more difficult. If we look at the polygon at the right and we copy it, and we want to state how many degrees we have in total and a proof of it. We're going to be able to say definitively and why. How can we do this? So take a minute. I believe. I got you.
I can pay for his crimes.
Crimes.
The first mistake
You
today
should have just backed it. You didn't learn how to parallel park. We gotta teach you some
the
skills.
first thing today that happened is my mom slept through her alarm.
Did you have your alarm set?
Nope.
Ah.
She is my alarm.
Levi.
My mom is my alarm.
Nope.
Wait,
Time to grow
what?
up.
Do you have a phone?
No, my parents make us put it in their room.
So if we're gonna use triangles here, how could we use triangles to defend? Whoa. So wait, in my mind, we've done a lot with triangles like from the center point, right? We did a bunch of stuff where we're like, from here we kapow, and so you're not saying do that. Jacob, I'm guessing you're not saying do that because I think I would end up with a lot more than 3. That we've done a lot of that, right? We have 3 each of the vertices. So you're saying do
One to like
this,
and then
Wait, there's a formula, isn't there?
this.
like that.
So let's go ahead and do this. A, B, C, D, E, F, G, H, I. Okay.
A plus B plus C plus D plus E plus F plus G plus H plus I equals 20 times 3.
So we have 180 in here. We have 180 in here. And we have 180 in here. Okay. How can we formalize this? So you just said the sum of all those things equals 180 times 3. Sure, but if we want to make this work in any case, bless you. I appreciate that you kicked it to the side, but try to vampire if you can. Try to get that arm up, catch those germs. Because they're your germs. You're okay to keep them, but now they're all over there.
Okay.
So
what you're saying is I can eat my own germs.
So you guys are mature enough to handle this. That just made me think of, there was this thing online that's like, humans are really interesting creatures. When we sneeze, we blast all of our germs, potentially like ill-infecting things at 70 miles an hour out of our mouth across the vast expanse of the room. Can travel like up to 12 feet or something. I think it's even further than that. And people respond by saying, bless you, and oh, poor honey, you must be like, oh, I'm so sorry. When we pass gas, it's a non-toxic, non-threatening, filtered through your pants, and yet people step away from you, they say bad things to you. It was just a funny, like, I'm going to shoot my germs all over everybody, and you're going to say, bless you.
But, see,
What?
the difference is one of them smells and one of them doesn't.
But one of them could get you sick.
Yeah, would you rather smell bad or
One of them
be
can
sick?
kill you.
I'll take option.
Well,
All right, Steven, how can we formalize this?
Okay, well, I know
What? His hand's been up the whole time, too.
Yes.
Steven.
I know the formula is like you take the number of side lengths and you subtract 2 and multiply by 180.
But
Yep.
why?
Is it
I know.
Because Mr. Morgan told us that in 4th grade.
Yeah.
So if we all, that's a lame reason. Mr. Morgan might be awesome, but saying just because someone told me is lame. We know a 3-sided figure has 180 degrees. We can then look and figure out that a 4-sided figure, a 2-sided figure would not be a polygon, has 2 sets of the 180. So 4 sides gets 2 sets. We can then see that 3, 4, 5 sides gets 3 sets of 180.
6 sides gets 4, 7 gets.
So if we start filling this in on our resource page, we have 180, 360, 540, 720,
900.
That worked out good. 1,000.
900.
1080.
Ooh, a 100 gone.
What's the track 90?
Oh no. Okay, so it's just 98 times 180.
No one can count that.
Just right,
Or
right,
make it life easy. What's 180
Lauren,
times
can you give me another
100?
calculator too?
180 times 100, that would be
8 if you're
well, 18,000.
Now take away 360. Right?
17,640.
Yep.
Quicker than you even got your calculator.
I didn't get my calculator.
So, if we formalize this into something using n, I think what Steven said was 180 times your number of sides
I'm not saying that.
minus 2. What? It's not a polygon.
Well,
Or-
one side
wait,
shape.
what? So a dot has an angle degree of -100. Huh.
Sure. So.
I'm gonna have to look into this.
Interesting.
So if I can put a dot there, subtract. So -1 times
How many
180.
sides does a point have?
Yes.
Infinitely many and none at the same time.
Well,
That
analysis.
doesn't make sense.
No, you.
So, Fern was unfortunate from the get-go because her parents named her Fern. But is helping her friend with her math homework.
Jeez.
Do you want the name of Fern?
No.
Friend.
I want to see how you spell that.
I mean, I like the name,
Isn't
but I
that
feel
like a plant?
yes, that's what I mean, my name's Mike, and I've had to spell my name for every person ever. So actually, maybe I'd rather have a simpler name.
It's so easy.
All right, so Fern says, now, is your friend Fern good at math? Or no?
It was like in kindergarten.
Oh, well, okay. So Fern says, I know how to calculate the sum of the angles of a hexagon, but how am I supposed to determine the individual angle measures?
You could make them in a bunch of different triangles and add up to 2 angles.
So
Side.
if we needed to write proof of this, sometimes mathematics is mildly repetitive.
Maybe.
So I heard make triangles that are isosceles, so I'm guessing you mean from here.
Yeah, and then you can just add them up knowing that each of those would be 60, and so you could.
What do you mean?
Oh, yeah, 120.
What do you mean we know each of those would be 6? Each what's?
Well, if you make it, is that a perfect or like whatever a perfect?
It's regular because it has.
Oh yeah, they're all So since they're all the same, you can assume that if you made an equilateral triangle at the center of it, then each of them would be 60, and so each of those angles would be 120. I'm bad.
So we're saying the whole central angle is 360, right? Including this one. So if I break that up,
That's gonna be
1, 2, 3, 4, 5, 6. So this has to be 60.
Yeah, and then you could
the
add
other
60
two
and
sides must
60.
also be 60.
The
So
base
it's really-
angle.
it's really-
Now be careful, because any gon that's not a hexagon is going to have a different central angle. But this process will work for any gon. So,
Just say Polygon.
what? Any gon.
Isn't any going
To me.
That's quicker than saying any polygon.
That sounds like.
And we start to say any
Anygon.
gons.
I choose you.
Okay. So we have an octagon, your stop sign, right? What are the angle measures?
Is that legal?
It's 360 divided by 8.
Now here's my challenge. Can you show me how to find that angle measure in a different way than
Oh,
what I just showed you?
God. No.
If so, you should be able to support it using the way we just went over.
Oh wait, I don't know how to do that. Mr.
Is
Hudson,
there
can I
a
make it a 10?
different way? I am not answering questions right now. You are just trying.
Use a protractor.
Nope. You have to be able to write it out as a proof.
Yes, the protractor will be part of the proof.
Need to recalibrate.
No, it's regular.
Work a blur on my nose.
It says.
I know, I'm going to write the process that we just did, but that's not what you should be taking. You're trying to find a new process, method to get that solved.
You can have one of those little shape thingies to make.
The templates?
Can I have one too?
Shop a template.
And you get a template, and you get a template.
You all get a template.
Can I have?
Thank
go
you.
up and explain
Micra, I guess.
Do you have it out on your paper?
No.
Then no. Why are you asking me that question before you've actually solved it, written it, and checked it? It's disrespectful to the fact that I already asked you and I shouldn't have to repeat myself.
Kinda. I didn't get it.
Just
Right.
do all the diagonals. Do the yada yada.
Steven, come on. Wait, what? You.
Wow, we only have 2 more questions
Wait, what?
on our notes. Yeah,
One more
this
time.
one's gonna take a year if you don't start the notes.
By the way, wait, what was X on the last one? Nope.
120.
Ah, 120.
Ah.
So if we know the base is isosceles, and we know we're going to use both of these, and there's another matching triangle right here,
Can we just divide it by?
I don't need to divide it.
It's just 135.
It's both base angles.
I am.
Right. This is both base angles. So we could easily know that it's 135, but my challenge to you is how do you solve it not using this?
When you say prove it, do you mean like make an actual like statement of reason proof? Or
You don't have to write it out, but we would need to be able to write it out saying, do this, and then you have that.
Oh.
And then you can,
Most
I see.
of these triangles are 180s add up to 1080, and the equilateral
There we
is
go.
also
I
equiangular.
figured it out.
If you divide one,
I figured it out. Except not. That's what I literally just did a minute ago. Like other than the thing you just did.
Mr. Hudson,
The
couldn't
thing
you,
that we did
Mr.
on
Hudson,
the worksheet.
boy, couldn't you make right triangles on like all the corners and then? No, but like.
Easier way to do it.
Okay, never mind. If I was just explain that what I was doing.
No.
I didn't. Okay, so what you could have done is like you could have made right triangles here, like and then top left, top right, bottom right, and bottom left, and then you could have made like I guess rectangles on the top, and the right, and the bottom, and the left.
Thomas?
You can do the same thing we did with these. We know that each of them adds up to 180, and as long as we make sure the angles are part of the angles of the octagon, then
So the easiest way to solve this angle, you're still saying, is draw these lines like across and make the triangles?
and since we know it's regular, we can just divide by
So to go back to what Satu was just saying, I think saying draw right triangles or something like that.
Hold on. Yeah, like that, like that.
I could draw all these straight grid lines.
And then you could
And then
do.
you know all the lengths of the hypotenuse. What is that going to do?
No, what you can I come up and explain?
Levi?
Um,
I'm just bouncing out of the room.
could I come up there and show it?
He just has the same thing. You talk it out.
Okay, so I just made the whole
Ooh.
octagon.
You extended.
Oh, Levi's
And
thinking.
then
Oh,
I
yeah, and then you cut the, and then you cut.
Take that.
Yeah.
I knew those were 90-degree angles.
Ah.
So
I
it
cut
was
it.
45.
This is extra, guys. What are you doing?
Because
Because
we're
I
SM
wanted to push you. So there are some lessons that I look at and I'm like, this is going to be lame with this group. Because remember, this is not an honors class, right? You might as well be because you're 2 years accelerated, but you are just accelerated. So this lesson's kind of lame, just a Polygon
Pretty
Henderson
lame.
theorem. I wanted to push you to think in different ways and not just reuse the same proof method for everything. So whether you cut up the inside or whether you surround the outside, there are many ways that we could prove how we get these interior angles. Other questions?
Oh yeah, yesterday we learned that Thomas kids who do STEM math for E don't count as people.
Oh yeah. It was.
Here's how I think.
Spills brain out.
Good morning. Please pardon the interruption. For our students that live in the Kilbourne Middle School attendance area, Kilbourne Middle School is having a dance this Friday, February
No.
22nd from
No.
7 to
No.
5 p.m.
Yeah.
If your neighborhood school is Kilbourne Middle School, you can purchase admission to that dance in the Phoenix office for $5. You must have Kilbourne as your neighborhood school to be able to attend that campaign. Thank you.
I mean, you get to see your friend.
Yeah,
It's
exactly.
your friends
What's not
video
good?
games.
They have video games at their canteen.
Or
No.
No, they're not going either because no one's going to be there. They just want to play video games.
What would my proof involve with the picture that I just drew?
Making a bunch of
Making-
triangle 45-degree.
Chris?
You need to know that the 45-degree angles are there because
How do I know that they're 45 degree angles?
it's the square and it's just a bisector of the two
and then you
angles.
could use CP.
And it's the diagonal which bisects
So-
the two sides.
I dropped altitudes. Right? You're allowed to say, I made this perpendicular. You can't just say this thing in the picture is perpendicular. Like, you got to prove it. But if you drop a line that is an altitude, I can say that's 90. Right? Here's a right angle and another right angle. If this is a square, which I'm easily able to prove, then this must be a diagonal that then is an angle bisector, and then this is 45. There's my 135. There's a lot of ways to do this. So, as you get deeper into math, I really want you guys, like, having in the back of your brain, like, there's not one right way. And when you think through one way that works, challenge yourself, try and think through another one.
There's 6.
Because when you revert back to just what's easy for you, you're not really growing. right? So gotta make that push. So that's good.
So like when you're scheduling like Miss Smith was talking to you about like taking like algebra and stuff like that. So like in this math class,
What school are you going to?
no, like further on.
Okay. Algebra and geometry and algebra 2 are all covered in our series. You'd be looking at whether you take like calculus or whatever beyond.
Yeah,
I'm
like,
only doing
in those classes do you only learn that subject, and then like this we learn a bunch of different subjects.
We took the integrated pathway, which means you learn algebra and geometry coupled together. That will continue to be the case for you here in Worthington. If you went to school like in Dublin, they took the traditional pathway, which you have like a year of algebra, a year of geometry, a year of algebra 2.
That'd be hard.
They still overlap a little bit, but not as much because we merged the content. Like I would say most days we do algebra and geometry, like just because they go together.
Wait, are those like the only two subjects?
I mean, they're the main branches of math. Calculus is an extension. There's branches of calculus. I mean, it's like the tree, right? Like you can go real detailed, and you could get a degree in a branch of mathematics. So then we can also use electronic tools to help us do this because you guys live in the age of electronic tools. Hopefully the machines don't, like rise up and come against us. But if you go into Desmos and this is way too zoomed in.
It's Desmos.
They have cool built activities here that let you play with things.
You could have been working at a place that did awesome stuff in making graphs, but now you're a teacher.
Looking at the place.
No, I still could. So always remember, we can extend both directions, but they do this intentionally to look at exterior angles compared to the interior angle. So what relationship do we know about this interior angle with its exterior angle? Linear pair. So sum to 180. So they're supplementary. Thank you. Just to pull out that vocab word again. So in all of these situations, if we know the interior angle, we can figure out the exterior. Right, so that is a tool that we can use. Where did we go?
Oh yeah, I have to ask you a serious question about math.
So do you realize that that was a lift between here's information, I'm about to give you more information, and you're like out here in left field just thinking about whatever you're thinking about?
I'll ask you once like the entire lesson.
So if we have a regular hexagon, and as you start to have these things memorized, we said the interior angle of a regular hexagon was 120. As I make a bigger shape, does this go up or go down? Up, right? Because my octagon was 135. Now, eventually, you might think of a rule that will work for that. But if we say these are supplementary, then my exterior angle, like angle A, would be 60. Can you relate that to another part of the shape? So like if I show you which one is this? Nope, still pentagon. Sorry, hexagon. Where are we? So if I reset this, if we have a regular pentagon, my bad. Should not have clicked all the way through here.
I think I know how to do it.
How do we find the interior angle if this was regular? Like it doesn't quite look like it.
Can I come up and see if I can do it?
Sure. Yeah, go ahead.
Wait, so does a circle have 4 sides?
Has one. One
But it's like,
continuous.
according to the equation.
We know that in triangles, like the sum of the two interior angles equals the exterior angle. So if we,
I know it's slightly off.
So go like slightly, it's like an inch. So we go like this. This one.
With his shades
Yeah,
and his
this
sweatshirt.
one.
and
If you
his
want to fix it,
sweatpants.
we recenter it.
What
Hit them both at the same time.
Shady looking sweatshirt on.
Sorry, I cleaned out the filter of my projector this morning, so it got a little goofed up, and I still think it's because it moves a little bit, it vibrates depending on if the heat's on. Yeah, from within a couple inches of it. Dang.
Feels like a game.
Yo, can I do the last one?
Yes, yes, you're doing it.
That's what everyone said in elementary school, dude.
Whoa, it's a game.
Whoa, it's a game.
mean, it's kind of like whack-a-mole.
He's on the last level.
Whack-a-mole
Hey.
doesn't move.
Okay.
High score. He was
It doesn't change at all.
He was too slow.
Perfect. Okay, so
Why?
this plus this equals this, right?
How is that
Um,
How is that any better?
What do you
Not
mean? This is
triangles.
perfect. I can draw a great circle.
Smartboard isn't the one that's bad.
So, wait, I think
So it's easier to draw.
if you go back to here, your explanation might be
Yeah,
easier
so
to
what I'm
explain.
saying, we know that the interior angles, like this one and this one, when you add them together, they equal the exterior angle of the other side, right?
Oh yeah, the remote interior.
Ah, so this is the remote interior angles theorem, right? To bring that back up, an exterior angle will be equal to the remote interior angles created from the triangle. So the interior angles A and B equal the exterior angle C. Now in a regular polygon, thank you very much, Chris, I appreciate you reminding us of that. In a regular polygon, there's also another trick to finding your exterior. So if we go back and look at your resource page, even.
I can't click on the resource page in my book.
Let's make another one around it, and then
Don't
see if it
work.
works.
If I went to
Canada's a nice place.
actually, I'm just going to go back to
It's freezing cold there.
So, Canada.
No humming class.
this octagon, right? What would the exterior angle measure in the octagon? 65?
What's 130?
No.
55.
50.
No,
40.
Where did you get 40?
Sorry, 40?
It is
55.
Did you just say 65 again?
No. 45.
What did we say this angle was?
No, it's no, wait, it's 80.
135.
This is a perfect example of how like we learn all this complicated stuff, but then forget how to do addition.
Perfect example of Satya being.
In a regular
Yo, it's actually kind of relaxing in here.
70.
this is 45. In a regular polygon, the exterior angles are the same measure as your center angles. And if you add up all of those from here and here and here and here and here and here and here, all
What do you mean?
all exterior angles of a polygon will sum to 360. Of any polygon. But regular ones are easier to look at and easier to think about. So if we look at the resource page on the back here,
Wait, what? There's a. Oh.
Woohoo! There. I'll have to later write.
We-
I'm gonna take a guess. Take off.
we could set a center point. We could create shapes. We could define points and angles and write a proof. But all we need to make sure has gotten through is if we summed A, B, C, and D, and notice that they have to go the same directions. So I can't like use A over here and then say I'm going to use another. Like, no. They will sum to 360.
Wait, if you did do that though, wouldn't the angle right there be congruent to angle A?
Yeah, but you can't use the two of them because then you're using the same
And then
angle
couldn't you
twice.
say that A and D add up to 180? No, never mind. I was.
Because it's not regular. Be careful. What you're saying is going down the road of like if it was regular. Questions? So big thing, big takeaways, right? Interior sum of these angles, right, is always 180 times n minus 2. That is the formula you want to memorize. ACT, SAT, all 180 times n minus 2. The sum of all exterior angles of a polygon equal 360, and we all know that the central angles all added up to a polygon equal 360 as well.
So what about
That's still for any polygon. The central angles of.
No, I know, but like.
Are you talking about exterior angles for irregular? It still works.
Yeah.
So like this is an irregular pentagon.
And we find the exact interior angles of an irregular.
We're talking about.
We can do a whole lot of things to do that.
Ooh.
So we can always drop altitudes, right? We can always create right triangles. We can always find those relationships between adjacent angles. It's the Dr. Smith method of just draw a line, start somewhere.
Who's Dr. Oh,
Some
you're,
odd one.
you're,
He was like one of my biggest math.
Is his first
Like
name
that.
John?
Jeff.
So close.
Thomas.
I made my calculator rounded up with 100 septillion sides. A regular shape that size would be close enough that each of the angles would be 180 degrees, that your calculator would round it to 180.
So it would look like an infinite shape.
Yeah.
Yeah. So as you get bigger and bigger shapes, right, it gets closer and closer to a circle. So you guys should go into Desmos and play with, like, make an n-gon. And then as your n gets bigger and bigger and bigger, like it looks like a circle, but it's not. But at some point, the shape stops even being realistic, because once you bend so far, it's like connected flat lines that are all flat uniquely. So think about infinitely many straight lines making a circle.
that's a circle, yeah.
That's like, but it's not a polygon then.
Wait,
But
so,
it is a polygon.
so a
So he
circle-
said it's like a 100 septillion gon.
So a circle is just a circle has one side and infinitely many sides.
Yes.
So wait, hold on.
But also neither.
But then a sphere.
So also no.
Huh.
What about?
All right. Are there any other questions dealing with polygons, interior measures? You can play with these if you want. You can get to these through your ebook. Yeah.
Can you make that shape in Desmos real quick?
I forget how easy it is to get to. Well, I was gonna let you guys work on your homework then. So of course you can start to practice if you want, but I will try to get into Desmos and do that for you.
Reality can be whatever.
My life has infinitely many sides.
Actually, I'm gonna freeze this.
See, if we had known this before we went to math counts, it would have been so much easier.
I'm sorry.
So there were like 3 problems that had this, and we might have placed. What were the words?
Well,
Wait, you actually
we're
write-
meeting today. We're still gonna have math counts today.
Good morning, Stars Campbell, please come to the office. Stars Campbell to the office, please. Thank you.
Wait, so who actually went to the math calc thing?
I did,
Thomas did, Levi did.
and you didn't. No, but
You went last year.
I didn't go last year.
No, not you.
I didn't think it was a thing last year. I thought it was the club, and I went to it a couple times.